for my field of like general aviation and small aircraft, it's definitely possible to get completely emission neutral, I would say, especially with or mostly with already existing technology like we proved.
Welcome to this latest Progress Voices podcast, the podcast series that's there to find out whether the world is just greenwashing or whether there are companies and organisations around the world that are actually doing some good to decarbonise our world and to combat climate change. Let's hope we find lots of people who are doing that, because if we find them, we can maybe inspire more of you out there to actually do some good. And if you want to find out how to turn sustainability into profitability, give us a call. Now, this has been an absolutely amazing week for us. We hit a humongous target with our podcasts. And I want to thank all of you guys that were involved in helping us to hit that target in just a minute properly. But before I do that, I'd also like to have a big shout out to my team who have done an amazing job to pull through so many different things over the last few months. And this week feels a little bit like one of those weeks where just everything falls into place. You know, after you put all the hard work in and then everything kind of comes to fruition, you can harvest all your labours. So I'd like to thank everyone in our design team for the rebranding of our website and our company. As you can see behind me, we've got a new company logo. We're super excited about that. We like to move with the times at Progress Factors. So please do give us your feedback about whether you prefer this logo or the old logo, which you can still find in our previous podcast films on YouTube. On top of that, we've also completely rebranded and relaunched our software suite. For those of you that don't know, we actually tried very hard about 5 years ago to decarbonize consultancy. That's our day job. We help other companies around the world to turn sustainability into profitability. And we like to lead by example at Progress Factors. So that's why we created that software suite. We've been collecting lots of feedback from you guys, and we've embedded it all into a new, fresh looking and also highly improved software. So we're super excited to start interacting with clients on that. If you want to know more about any of this stuff, go to progressfactors.com. But as you know, this shouldn't be an advertising platform for us. We're doing Progress Voices to inspire other people. So let's get back down to the podcast. Now, we are so amazed that we've managed to do this, but you might have already seen the eGenius film on YouTube. If you have, then you're one of 25,000 people, meanwhile, that in less than 2 months have watched this film. We got the first 10,000 within the first week. And then, of course, YouTube started putting adverts on our YouTube channel. That slowed things down a bit, but still 25,000 people. Absolutely fantastic. Thank you very, very much, with or without advertising, for being one of those 25,000 people. Thank you as well for all your comments and for subscribing to the channel as well. The comments are really good. Please do keep them coming and give us your suggestions about what kind of films you'd like us to take, what subjects you'd like us to delve into, which companies you'd like us to contact. And if you're working at a company that you think has got some kind of awesome news about what you're doing to save the planet, how you've changed your business model, reach out to us. We'd like to talk to you. Now, this podcast is a follow-up to the eGenius film, the one that just got 25,000 views. And we're really, really lucky. You probably, if you've seen that film, you remember a guy called Stefan Zistler. Stefan is kind of like the program manager for the testing of the eGenius aeroplane, the one that he built together with some other people at the University of Stuttgart. And after actually testing the plane, he took some time out to sit down with us and actually talk a little bit more in detail about the background of the project, why it's so important for the world, where the benefits are, and also to delve a little bit deeper into the technology. But before we start actually watching that, I'd just also like to give a big shout out to obviously the University of Stuttgart themselves, where Stefan works in the Institute of Aircraft Design, and also the Institute of Flight Mechanics and Control, who built the autopilot system that was tested along with other things in the eGenius project. Big thank you to all of you people for doing really fantastic work, and also for allowing us to join in and film your work. And of course, we also need to say a big thank you to the German Federal Ministry of Economic Affairs and Climate Action, because eGenius is part of the SiFlA LUFO V1 project. Now, don't try and say all of that if you've been to the dentist, but I hope I got it more or less right. I'd like to thank the people who've been sponsoring this whole program. It's great to see ministries and governments getting involved in decarbonising our skies. So without any further ado, let's get down to the actual podcast itself. Stefan Zistler, thank you so much for having us here to the Stuttgart University IFB, the Institute for Flugzeugbau, the Institute of Aircraft Design, I believe. Thank you so much for having us. We met end of May, and you were just getting your eGenius aeroplane ready for the next test. How has the summer been for you?
Yeah, welcome back first. It's great to see you again here. Our summer has been quite successful. By the end of May, we had all the conversion work examined that we did in the winter, and then we flew again in the end of June, and yeah, but quite successful. Yeah, I'm the main research pilot here at the Institute. I do most of the flight tests with the eGenius, but for the first 2 flights, I think we had a certified test pilot in the left seat, and I was in the right seat because I designed most of the propulsion system that we changed during the winter, so I could supplement him really good from the right seat.
And how does that feel when you've actually, created a new kind of propulsion system? You built it into this, as we call it, flying test bed, and you're actually flying for the first time, regardless if you're in the left or the right seat, on your own or with somebody else. But how does that feel?
It's awesome. We worked on it for 2 years, and I spent lots of hours inside that fuselage, really tinkering with all that stuff. And if you finally get to test it, it's really cool. But on the other hand, of course, we were very focused on what we were doing. So that was like 90% of our thinking, and then you only realize in the end that what you have done. Yeah.
It's the sort of day you get really tired by the end of the day, and you can't tell anybody why, right? And you're concentrating all day long. Huh?
Exactly.
And I know the use case. It's a very special use case, and I think we've got another bit of film we can show in a second. But it's very close to your heart. Could you explain to us what were you testing? Why were you testing?
Yeah. So the changes of the propulsion system mainly were a power upgrade. So we have higher takeoff power and higher continuous power. We installed a different electric motor, and we installed a different energy storage system. So we switched back from the hybrid system that we had with a diesel generator that's good for long range cruise. Switched back to battery electric propulsion system because it can supply higher power outputs for a shorter time. And we use that to allow the eGenius to tow gliders. So there's 2 main launching methods for gliders. You can either tow them with a winch, which is very cost effective, and you can use another airplane to tow them aloft. That's aero towing, and that's what we intend to do or have actually done with the eGenius.
Okay, and if the winch is so cost effective, why don't people do it all the time?
The limitations is you always get released at the same point at the same altitude. So aero towing gives you a larger freedom of where you want to go and how high.
Okay, so you can find the right
thermal set.
Thermal set is the word I was looking for. Thank you. Yeah. Okay, so this is brilliant. So I mean, do we really need this technology? Is this something that's worth researching into? You're obviously passionate about it. I think you're not just a pilot, you're also a glider pilot, right?
I'm a glider pilot. I started as a glider pilot at the age of 14, so I know all the shortcomings it still has. I mean, we still use kind of old planes. There's been some developments with conventional combustion engines as well, but aero towing is still quite fuel intensive, and thus expensive. Yeah, so
okay, and
it's still definitely worth research. Yeah.
So it's expensive in terms of money, but it's also expensive in terms of the environment, I guess, right?
Exactly. A typical Lycoming equipped tow plane uses like 45 to 60 liters per hour when it does towing. So you use a few liters of F-gas, leaded F-gas, and in comparison to a few kilowatt hours of battery energy that we use.
So let's go through the maths there, because I mean, a plane like this, it's going to be pulling up gliders into the air, towing gliders. It's not going to be flying the whole time, right?
No, typical flight times are 10 to 15 minutes, and you burn roughly approximately 10 liters during that period. For a typical standard altitude is 600, 800 meters, something like that. And we used 5 to 6 kilowatt hours with a single seater for the same altitude.
And I think you told me as well, the other thing is when you come back down again, you're creating energy on the way down. Is that correct?
That's another neat feature of electric propulsion for aero towing. That's correct. Because a conventional tow plane even uses fuel on the way down to limit the cool rate of the engine. So you still have a little gas in there to stop to avoid cracking in the engine. And we can even harvest some energy on the way down. Yeah, so we can use the propeller as a windmill basically, and have some current that charges.
Generates some electricity then.
So in that for 5 kilowatt hours that you need on the way up, you get back 0.3 to 0.5 on the way down. So it's a little percentage, but it's better than wasting it.
Okay, but I mean, that's like maybe every 20th flight for free then, right? Yeah, I mean, that's the way you got to look at it. Okay, so that's great. So what we're saying is we've got a plane that can take off using less energy. It's got less emissions as well, right? It's pure electric, so as long as it's green energy, then
it's got zero local emissions.
Okay, and it also is creating a bit of energy on the way back down instead of costing more energy as a traditional plane would do.
Yeah.
And I know your goal was to try and get a 600 kilo aircraft in the air. How did you do on that? When we spoke in May, that was the biggie. But how were the results?
Yeah, that was the initial calculations that I did back when I was doing my master's thesis about this topic. And the first actual aero tow we did with a single-seater Discus CS with 360 kilo, just to be on the safe side, of course. And then we, as soon as we realized we had reserves in the climb rate, we stepped that up, or especially in the takeoff run. So what limits you there is the takeoff run, basically, that you have available. And we stepped that up until we reached 750 kilograms with a fully loaded Arcus.
Okay, and I remember you told me as well, it's all about the angle of getting into the air. You know, you're looking for the steepest angle of ascent. Is that correct?
That's correct. When I was doing those calculations, I found out that the quicker you get to altitude, the more efficient it is, because when you fly around, you create a certain amount of drag, and the shorter the time you need to get aloft, the better your efficiency is. So every kilowatt of excess power that you can put into climbing helps with your efficiency.
Yeah, well, I tell you what, I think you could probably sell this thing at London City Airport, because they're some of the steepest I've ever known. But anyway, yeah. Okay, so that's great. So you're trying to get into the air as quickly as possible. If I understood correctly, you said that basically having a peak of energy is great for batteries, right? And would you say that we're going to go all electric in the future for long range aircraft as well?
For long range, it's a little different, because the mission that we have for aerotow flights really suits battery electric propulsion. You have short flight times. You can think of a quick swap system for the batteries, because you always land on the same airfield that you took off from. So it's really a different and a special mission. But we also have solutions for long-range air travel with, like we demonstrated with our hybrid, which can fly 2,000 kilometers, which is a world record for this aircraft class. And also, we might see a fuel cell flying in the eGenius in the next 2 to 3 years to also demonstrate the potential of that energy storage system.
That would be excellent. So a fuel cell, we've done a podcast as well with a company called Zero Avia. And they do fuel cell systems. So you take something that's basically just hydrogen energy and use that hydrogen to create your own electricity whilst you're in the air. So you're generating your own electricity in a similar way to what you did with your record breaking flight, where you flew for 2,000 kilometers, purely electric on eGenius, but you were creating that electric with carbon fuels. Yes. It was a great test. It was a breakthrough. Yeah. If we can replace carbon fuels with hydrogen, would be even better.
You still need all the key components that we have in the eGenius. So you need an efficient propulsion system like we have, and then the good aerodynamics that the eGenius has close to a glider. So really refined aerodynamics, the good propulsion efficiency. That's still key technologies that are suitable for both, for this small aircraft, also for larger regional aircraft.
Excellent, yeah. No, and I remember you said as well with the eGenius that it's so much like a glider. You can actually kind of glide up with the glider. You can use the updraft to your own advantage when you're towing, right?
Yeah, exactly. eGenius has an L/D of about 30, which is pretty good for an aircraft. Not so good for a pure glider. Okay. It's in between, and it can use the updrafts. Yeah, but conventional tow planes can do that as well. It mainly depends on the diameter of the circle, the turn that you can do.
Okay, and what's an L/D?
L/D is the glide ratio. So it's the ratio between the lift that you produce and the drag that you produce.
Okay.
For 30 kilos of lift, you would produce 1 kilo of drag.
Okay.
Drag you have to overcome with your propulsion system. So it's also a form of efficiency. How efficiently can you create your lift force.
Yeah, I see. So we're basically talking about two aerodynamic principles that are working against each other. It's about how easily do I get through the air and how much do I use the air to gain height. I'll never forget going on a sailing holiday. We took a catamaran out for a couple of weeks and we had a skipper with us. And even when we didn't have any wind, she'd still have the sails up. And I was just amazed to see how efficient that catamaran had been at the end of the first week when we put the first tank of fuel in. I was sweating, to be honest, because we didn't have too much wind. But it really makes a big difference if you can use the aerodynamic forces to your advantage, right?
Also for powered aircraft that do cruise flight, because the less drag you create for the lift that you need, the less power you need, the less energy you need to get forward.
Now, before we carry on with the podcast, I'd just also like to mention again that my company Progress Factors is sponsoring these podcasts at the moment. Do go to progressfactors.com if you want to find out why we're doing this and get some more information about it. And also, if you'd like to become a sponsor of this podcast series, if you'd like your company to be mentioned for a company that really believes that we should do some good in the world, then please reach out to us. We'd love to get to know you. And at the same way, if you're working for an organization where you think there's something interesting that we should be making a podcast about, reach out to us as well. You can contact us on LinkedIn. You can contact us over our YouTube channel and just put some comments on some of the podcasts. Or you can also, of course, just go to our website, progressfactors.com. There are plenty of buttons there for get in touch, organize a demo, and all those sorts of things. It would be really great to speak to you and, to get in touch with you.
You told me as well that you got like larger than 600 or more than 600 kilo planes. But what's the point? Why would you want a heavier glider? Is it just about having more passengers, or is it all the GoPros that people are sticking on them these days? Where do the kilos come from?
By the way, the 750 is, I think, the heaviest glider that has been towed electrically.
Okay. Wow. So another world record, huh?
I don't think it's an official FAI world record, but we still claim it.
Yeah.
So the number of people a glider can carry is limited by the certification specifications to 2, so that's out of the question. But gliders nowadays take advantage of a higher wing loading, so they actually carry water ballast.
Okay.
They don't try to be as lightweight as possible because with a higher wing loading, you have a higher better glide performance. Your best glide speed switches to a higher speed. So and you can still use the updraft. So if you have good soaring weather, so strong thermals, then you have a higher cross country speed. So your average speed over a certain distance increases with the wing loading. That's why they carry water.
I guess that makes sense if I think about a leaf like in the wind or whatever. The leaf's just going to go wherever the wind wants it to. What you're saying is putting water into the wings?
Yes, in the wings, yeah.
Putting that into the wings means that you've probably got more momentum, that you're going in the direction you want to go,
Yeah, kind of. It changes the angle of attack of your airfoil, basically.
Okay.
You don't create your lift with angle of attack, but with airspeed, basically. So the same, and that the optimum LOVD is always at the same angle of attack, and you have that angle of attack at a higher speed. That's why.
I see. I'm with you. Okay, just the same as accelerating to take off on the runway. Okay. Okay. Oh, that's interesting. Now tell me, just with the things that you've been testing here, I know you're a very generous guy. You haven't just been testing your own technology. I mean, this is your invention. This is something you've been working on building and everything, but you've also been testing stuff. It's part of a larger project, right?
Yes, exactly. It's a federally funded aviation project, and we have 3 partners, so we have 4 partners. It's 2 institutes of the University of Stuttgart, so our institute, the IFB, and also the IFR, the Institute of Flight Dynamics and Flight Controls. We also have 2 industry partners, namely Air Energy, who developed and supplied the batteries for the project, specifically for that use case. And we have Air Avionics, Garrecht Avionik also, who supplied the displays that we use for our assistance systems.
Okay, and you've actually got like an autopilot in this plane as well, right?
Exactly.
Is that down to laziness? Were you having a cup of tea in the air, or what was happening there?
No, it's the same idea that they have in the commercial airliner cockpits, that it reduces the workload that you have, because flying a tow plane is really a hard job. You have to hand fly that aircraft with a glider behind you who is disturbing you. You have to look for updrafts that you can use. You're flying through congested airspace out of that airport you're taking off with all the gliders around, so you have to look out very, very good for traffic. And you also have to avoid noise-sensitive areas, because all the people that live in villages close to the airport don't want 20 aerotows going over them in one day. So it's a lot of tasks that you have to manage at the same time.
Okay.
If and our assistance system tries to help you with that by flying the plane for you, and also it can plan your flight path accordingly, so you avoid noise-sensitive areas.
Okay, so you basically got an intelligence in there that's saying, okay, we're going to fly somewhere where we're not disturbing residential areas then.
Exactly, yeah. And also it can pick up traffic signals from like traffic receivers that are already out there, and basically all small aircraft are equipped with, and it can avoid this.
Oh, so it's automatic collision avoidance.
Yes, exactly. Yeah,
excellent.
That's the goal. We still have to demonstrate that.
Okay.
But yeah, that's the goal.
So that's the next step of the test, right? Have you finished with all your tests with towing? And will you carry on towing when you're testing other stuff?
Yes, so we have done, I think, 12 or 13 towing flights that demonstrated the performance of the propulsion system itself and the efficiency. And now we have to do the towing with the autopilot active and with that intelligent path planning, so we can see how that works.
Okay, then. And how do you feel about that? Do you think it's going to be safe with the autopilot? Or
we actually had switched the autopilot on yesterday for the first time.
Okay.
Without the glider, and it was performing quite well. There's still some fine-tuning to do, but it's really fun.
Where you just like hands-free flying?
Yeah, and it turns.
Well, I mean, I guess the aviation industry invented fly-by-wire, right? If we see all the technology we see in cars these days, it's all come from the aviation industry.
Yeah, so that by itself is not the big deal, but implementing all that together into that specific flight mission, that's really the new stuff.
Excellent. Well, it sounds like we're really on a success curve here. Sounds like you're, not just achieving, but overachieving all the goals that you've been set. And it sounds like you're working on something that you're passionate about, that you want to make a difference in the world. I mean, must be just great to be here at the IFB. And I don't know, we spoke once before about, your history, but maybe you can just give us, just for 5 minutes, a little bit of your own personal history, how you managed to do this job today.
Sure. Like I've said, I've been a glider pilot since the age of 14. I basically grew up on a small airfield in the vicinity here. So my passion was always about flying. And then there were some phases where I thought about making it my profession as well. But I ended up studying mechanical engineering first as a bachelor's degree, and then switched here to the University of Stuttgart for my master's in aerospace. Okay. And that really was a good step. And I became involved in the eGenius project from the beginning. Mm-hmm. So when I started studying here, I applied as a student assistant, and so worked on the project. I've worked on the project for over 6 years now.
Okay.
And it's really cool to get hands-on experience, or if you bring hands-on experience, you can really develop that further here.
Okay.
So that's really cool that uni has those two projects. Especially the eGenius and the eCarrier, that are manned aircraft that you can work on.
So what would you say to the next 14-year-old, regardless if they're a glider pilot or not? Do you think this is an industry people should get into, or is this a dying industry? Are we all not going to fly in 10 years' time? What's your advice to the next 14-year-olds?
Yeah, definitely get into aerospace. You don't have to be a glider pilot, although we have many of those here. The cool thing about especially our master's program here is the versatility. So you can really choose your field that you want to go into. If you want to focus more on space travel, on software development, coding, on structural development, actual aircraft design like we do here at our institute. But there's definitely a lot going on, especially, of course, moving towards green aviation. So it's really a very cool field of engineering, definitely.
And what about green aviation? Is it just a myth? Is it all just greenwashing, or can we actually look forward to flying with a good conscience in the future?
Especially for my field of like general aviation and smaller aircraft, it's definitely possible to get completely emission neutral, I would say, especially with or mostly with already existing technology like we proved. It'll be a longer and more difficult road for everything that's larger than that, but we are also, of course, working on that, and can change a lot of things, I would say.
All right. Well, you heard it here, folks. This is the place to come if you want to actually be part of that pioneering team that is going to hopefully make sustainable aviation over the next 5, 10, 20, 40 years a reality. And it's fascinating for me. It's really been a great interview again. Thank you for finding the time for this podcast. And, Stefan, all I can say is thank you for all you're doing to save our planet and to prove that, that we can actually achieve these kind of goals. Really take my hat off to you. A hero of aviation pioneering.
You're very, very welcome.
Thank you so much for watching or listening to this podcast today. If you are watching on YouTube, I do hope you like our new CD, our new corporate design, and I do hope you take a little bit of time wherever you're listening or watching this podcast to pop over to progressfactors.com and find out why we're actually putting all the effort into making these films and these recorded audios for you guys. We'll be back with some more podcasts soon. Really looking forward to finding out even more about which companies are doing amazing things to save our planet in the future.